Hello everybody, welcome back to Channel ANZ Machinery. The manufacturing of large industrial gears is an impressive combination of cutting-edge technology, precision engineering, and sheer industrial power. This modern process begins with forging, a critical step in creating seamless rings and rolling shells, setting the foundation for the gear's durability and strength. Forging starts with heating massive metal ingots to high temperatures, rendering them malleable for shaping. These red-hot billets are then pressed or hammered into shape using powerful hydraulic or mechanical presses. The result is a robust, seamless ring or shell with exceptional structural integrity, perfectly suited for high-stress industrial applications. Once the forged pieces are formed, they undergo precise rolling to achieve their final dimensions, ensuring accuracy and uniformity throughout. The next stage involves milling and cutting, where state-of-the-art CNC machines come into play. These machines, renowned for their precision, are tasked with cutting grooves and shaping gear teeth. The process starts with rough machining to remove excess material, followed by fine milling to achieve the desired specifications. Advanced tools like hobbing or shaping cutters carve out intricate gear profiles, ensuring optimal performance under load. This meticulous process is exemplified by companies like Horsberg and Scott, a leader in industrial gear manufacturing. Known for their expertise in crafting gears for heavy industries, their CNC-driven manufacturing ensures gears meet exacting standards for performance and durability. Each step, from forging and rolling to milling and cutting, is a testament to the incredible advancements in heavy industry and engineering. These modern techniques not only enhance the efficiency and accuracy of production, but also ensure that the final gears can endure extreme conditions, powering critical machinery across the globe. The awe-inspiring synergy of raw industrial strength and technological precision makes modern gear manufacturing a fascinating spectacle, highlighting human ingenuity in engineering excellence. The production of large gears has evolved with advanced forging and CNC machining technologies. Modern methods allow the creation of durable, high-precision gears capable of withstanding extreme industrial demands. Massive gear blanks are forged under intense heat and pressure to ensure optimal material properties. CNC machines then carve these blanks into exact specifications, achieving unparalleled precision and efficiency. Integrating lean management principles optimizes production processes. Techniques such as just-in-time manufacturing, continuous improvement, Kaizen, and waste minimization enhance productivity while reducing costs. By aligning workflows and eliminating bottlenecks, manufacturers achieve faster lead times and improve product quality, crucial for large-scale gear production. Evaluation and documentation of the physical contact patterns between gears are essential for ensuring proper load distribution and operational reliability. Using advanced measurement systems and software, engineers can assess gear meshing accuracy and pinpoint wear or misalignment issues, reducing downtime and maintenance costs. Grinding bevel gears with diameters up to 1,100 millimeters is now more economical, thanks to specialized grinding machines. These systems use efficient abrasives and precise tooling to achieve desired surface finishes while minimizing material wastage. This process ensures high performance for gears in industries like aerospace and heavy machinery. Grind burn, a thermal defect during grinding, can compromise gear integrity. Advanced detection techniques, such as eddy current testing and thermal imaging, are now standard. These methods identify even microscopic defects, ensuring that all ground bevel gears meet strict quality standards. Modern gear forging and manufacturing processes have reached unparalleled levels of precision and efficiency, exemplified by the use of advanced technologies like the Faro Arm Coordinate Measuring Machine, CMM. At Horsburgh and Scott, this state-of-the-art tool enables engineers to meticulously measure all gear surfaces, ensuring superior accuracy in gear tooth fittings. The Faro Arm CMM's precision capabilities are pivotal in producing large, high-quality gears that meet rigorous industry standards. By capturing detailed 3D measurements, it minimizes errors, optimizes designs, and guarantees the perfect alignment of gear components. After the intricate gears are meticulously crafted and ground to precision, the next phase in the journey begins: assembly. In a large gear assembly plant, this process is an orchestration of speed, accuracy, and innovation, ensuring each gear is seamlessly integrated into its destined system. Fast forward to the bustling assembly floor, where state-of-the-art machinery and skilled technicians collaborate to build complex gear systems. The process begins with quality checks on the ground gears. Each component is inspected to ensure it meets stringent specifications, as even the slightest imperfection could disrupt the harmony of the assembly. Once cleared, the gears are moved to automated assembly lines. Here, robotic arms equipped with precision tools take over, aligning and fitting gears into pre-designed configurations with unerring accuracy. These robots not only accelerate the process but also eliminate potential errors caused by manual handling. The symphony of whirring motors and clanking metal is a testament to the cutting-edge technology driving the plant. As gears are paired, lubricants are applied to reduce friction and ensure smooth operation. Advanced machinery runs initial testing cycles, simulating the conditions the gears will face in real-world applications. These tests validate the assembly's functionality, durability, and reliability. Meanwhile, technicians oversee the process, ready to intervene if anomalies arise. Their expertise is indispensable, ensuring the technology runs at its peak and troubleshooting issues swiftly. Once the testing phase is complete, the assembled units are prepared for packaging and distribution. The plant's efficiency lies not just in its technology, but also in its synchronization of human skill and automation. Each step in the assembly process is streamlined to meet the demands of modern industries, where high-quality gear systems power everything from automobiles to industrial machinery. In just a short span, what began as raw components are transformed into critical components of advanced systems, ready to conquer challenges in their respective fields. The journey from grinding to assembly is a marvel of engineering excellence and production efficiency.